Hi, welcome to the video lecture on neural networks and introduction. If you look into the history, so in 1943, McCulloch-Pitts introduced the concept of neurons. Then we have the Hebb's law. Then in 58, we had the concept of a perceptron. Then sometime in 60s, we have the Adeline neural network. Then in 69, we had certain limitations that were published by Minsky. Then we had 3 years later something on coherent nets and associative memory. Then sometime in 1988, we had something called character recognition. So backpropagation was introduced in 86, and this is how. And Hopfield network is another important thing introduced in 82, and this is how the concept of a neural network has evolved over time. If you look into the definition of a neural network, so a neural network is a simplified model of the biological nervous system. So it has drawn its motivation from the king of computing performed by human brain. So what is a neural network? It is nothing but an interconnection of network elements called neurons. Each of the neuron has its own local memory. The neurons are connected by communication channels. Each link has an associated weight, and this link and the associated weight will be useful in processing the information used by the network. So if you look at what is called an artificial neural network, otherwise termed an ANN, ANN is nothing but a computing system inspired by the biological neural network. So if you look at such systems, so these artificial neural networks basically improve the performance by considering examples, generally without task-specific programming. So for example, if you look at the slide here, we have several breeds of dogs, and then you give it into a training. So where is the dog in this picture? Then obviously without a neural network it is going to be difficult. If you have humans and then one dog in the picture, probably it is easier to identify. But when you give a breed of dogs, definitely without a neural network it is going to be difficult. So what does an ANN basically do? So an ANN basically does what is called the training. So it will be able to identify the dog from the picture where people are standing there and the kids are there, along with it there is a dog. So in the training set I have about 4 different breeds of dogs, so it's able to identify the dog in the picture. Simple, right? So which means an artificial neural network definitely requires some kind of training, and the systems will learn progressively by improving their performance, and they will do a specific task by learning from examples, and generally without a task specific programming. So what is the idea behind an ANN? So the ANN basic concept is driven from the neural networks that will learn the relationship between the cause and the effect. Or it will obviously organize large volumes of data into orderly and informative pattern. So if you look into this, so you have a frog, you have a lion, and you have a bird, and if a kid asks his grandfather what is it, the grandfather will be able to identify it is a frog. So when you talk of a neural network basically uses the concept of what is called the information processing paradigm inspired by biological nervous system, such as for example our brain, or it could be a structure where it is highly interconnected processing elements working together, and I call all these highly interconnected processing elements as the neurons. Or a neural network could also learn from experience or example, like our people here. So if you look into the definition of an ANN, an artificial neural network is a data processing system which is made up of a large number of simple, highly interconnected processing elements. And I call these processing elements as neurons, very specifically artificial neurons, in an architecture inspired by the structure of the human brain. And when you look into the specific part of the human brain, I would relate it to the cerebral cortex. This definition of an ANN came into existence in 1997. When you compare and contrast an artificial neural network with the conventional AI methods, when you look into the processing style, traditional computing, including expert systems, are all sequential, whereas ANN is parallel. So if you look into the functions, traditional computing basically relies on the rules, concepts, and calculations, whereas ANN basically relies on images, pictures, and so on. Traditional computing, including expert systems, learn by rules, and ANN basically learns by what is called learning by example. If you look at specific applications of traditional computing, you will have accounting, word processing, digital communication, and so on. Whereas if you very specifically look into ANN, so you will have sensor processing, speech processing, pattern recognition, and so on. So what is an artificial neuron? An artificial neuron derives some characteristics, common characteristics with biological networks. So several key features also are suggested by the properties of a biological neuron. The processing element receives many signals. Signals may be modified by weights. The processing element, the weighted inputs, the output from a particular neuron may go to as many other neurons as well. So an artificial neuron basically learns from examples or training data. That is what we say. An artificial neuron basically learns from experience. The strength of the connection is basically called as what is called the weight. So learning the solution to a problem is equal to changing the connection weights. So that is how, changing the connection weights suitably will, change the learning pattern. So, these are basically developed as mathematical models generalized from neural biology. Assuming, information processing occurs at many simple elements called neurons, signals are passed between neurons, then each connection has an associated weight, and then each neuron applies an activation signal. When you look into the model of a neuron, we have the set of inputs written as x1, x2, x3. Then I have connection weights called W, A, B, C, and so on. And x1, x2, x3, the input units resemble the dendrite. The connection weights basically resemble the synapse. Then you have the summing function and the computation, both together resemble the soma of the human brain. Then you have the output Y basically that resembles the axon of the brain. And this basic diagram basically shows how a neuron could probably resemble a neuron probably present in the human brain, right? So a neural network consists of large number of simple processing elements. I call it as a neuron, a unit, or a cell, or a node. You can call it with different terms. So each of these neurons need to be connected to other neurons, and They are connected by means of weight. I call it as an associated weight, and they are all directed communication links where it is arrow-headed. So the weight basically represents some kind of information being used by the network to solve a particular kind of a problem. So each of these neurons obviously have something called, the activation level. So this activation level is sent by a neuron as a signal to other neurons. So what is important to note here is a neuron can probably send only one signal at a time, although that signal is broadcast to several other neurons as well. So neural networks are configured for a specific application such as pattern recognition or data classification through a learning process. In a biological system, learning involves adjustments to the synaptic connections between neurons, and the same is true for an ANN as well. When you look at the properties of an artificial neural network, again to stress, ANNs learn from examples. It could be labeled or unlabeled. They are highly adaptive in nature, where changing the connection strengths could obviously improve the performance, or certain times it can even degrade the performance as well. Then it has something called generalization ability, fault tolerance, and non-linearity. So in order for the artificial neural network to work properly, we have already seen earlier in the presentation, the video uploaded earlier, that non-linear activation functions are better than linear activation functions. So an artificial neural network might definitely require a non-linear activation function to get trained and to work in a better manner. So if you look at the artificial neural network, a neuron will basically receive an input, determine the strength of the weight of the input, and then then you compare the total weight with the value, and the value, I call it as a threshold. The value normally lies in the range 0 to 1 and so on, right? So if the total weighted input is greater than or equal to the threshold value, then the neuron will produce the output. Yeah, that is the condition. So when you go for training an artificial neural network, what are the basic steps you need to know? First, you decide the architecture, then you decide on the number of inputs nodes, then you decide on the output nodes, then you prepare the training set, and the training set must contain many examples so that the network becomes familiarized with the problem. So if the network training is supervised, you provide the network with a set of desired outputs, and then you train the network, and then you test the network. Obviously, the training and the testing data obviously needs to be different. So when you look at characterization of an ANN, it's based on architecture. For example, you can have a single layer feed forward or a multi-layer feed forward or recurrent network. So this basically depends on the type of connection between the neurons. Then you can also characterize it based on the strategy or the learning algorithm. So it could be either supervised or unsupervised or reinforced learning. You can also characterize it based on the activation function. So it could either be linear or non-linear. Always non-linear is preferred over a linear activation function. So where can normally neural networks help you? So when you cannot formulate an algorithmic solution, neural networks are helpful. When you can get a lot of examples of behavior, it's called learning from experience, then neural networks obviously are useful. When you need to pick out the structure from the existing data, again, neural networks will be helpful. So who would obviously be interested? Everybody is interested, right? From electrical engineers who do signal processing to control theory, to computer engineers who work on robotics, computer scientists who work on AI and PR, and mathematicians working on modeling tools. when the explicit relationships are not known, and artificial neural networks finds its applications in a wide variety of engineering fields. What kind of problem domains can be supported using ANN? Storing and recalling patterns, classifying patterns, mapping input into outputs, grouping patterns, or finding solutions to constraint optimization problems. So this is how probably you can apply an artificial neural network. I have a set of inputs. I want to probably detect a coronary disease. Then I train the network, then I test the network, then probably I do some kind of classification to determine the true positive, false positive, true negative and false negative, and so on. Then compute the accuracy. I can also do clustering where you probably try to put it in several different buckets. So ANN has a wide variety of applications like in chemistry, education, medical applications, very important, information searching and retrieval, business and management as well. So you take any kind of an application, neural network will be best suited as well. So these are certain applications, right from signal processing to PR to disease diagnosis, speech recognition, human emotion detection, and educational loan forecasting. So if you look at the applications like investment analysis, signature analysis, speech and vision recognition, monitoring, and marketing. If, for example, if you want to detect an abdominal pain prediction, there could be probably several kinds of parameters like gender, age, temperature, the WBC count, the intensity of the pain, the duration of the pain, and so on. So it could be because of different kinds of symptoms like appendix or ulcer and so on. So you want to probably find out that that could be definitely possible by using an ANN. Voice recognition is also possible. Yes. Education loan forecasting system is definitely possible using artificial neural network. When you look at investment analysis, it predicts the movement of stock from the previous data. Here you could probably employ a linear model. Then you use signature analysis, where you can probably compare your signature with the already stored signature, and this definitely finds application in banking systems. Then you have probably speech and vision recognition. Toys with the ability of neural network chip the system is designed to recognize simple entities, simple commands like stop and go. All these are possible with ANN. Then pen PCs you use, when you can write it on a tablet, it recognizes your writing, then translates into text using ASCII codes. Yes. Monitoring, to monitor the state of the aircraft by monitoring the vibration levels. Early warnings of the engine problem can be predicted. When you look at probably marketing, it is basically used to improve marketing mail shots, where you have a test mail shot is run and it recognizes the pattern of these mail shots. So neural networks has a wide variety of advantages, where you can say it is massively parallel, adaptive. You only need less effort for characterization of these problems. You cannot program it, but ANN definitely learns from examples. ANN is definitely robust in nature. It is fault tolerant. It obviously has what is called mapping capabilities, generalizes the input, and it's also can process information simultaneously at a very high speed and also in a distributed manner. So it is non-linear. it can derive a relationship between the input and output. So there is something called the input output mapping. It's highly adaptive, and there is always an evidential response. So contextual information is also a key advantage of a neural network. Every neuron is potentially affected by the global activity of other neurons. So fault tolerance, the distributed nature of the neural network, gives this capability of fault tolerance as well. Neural networks also probably model the architecture of the human brain, and hence you can talk of a neurobiology analogy with a neural network. There are a few disadvantages of the neural network, and these disadvantages basically are very, very less compared to the advantages. Some of the disadvantages of a neural network are, there are no clear rules or guidelines defined to design an ANN. There is no general way to access the internal operation of an ANN. Training will be difficult, but it is not impossible. Once you learn the things of a neural network, definitely an artificial neural network is going to be much, much effective in solving a lot of real world application problems. So this presentation has given an overview of what is a neural network, what are the kinds of applications that can be solved using the concept of a neural network, what are the fields of engineering that can effectively use neural networks. We have also discussed the characteristics, the advantages and disadvantages of artificial neural networks. Stay tuned for more video lectures on my channel. So this concludes an introduction to neural networks. Thank you. Meet you soon.